Welcome to packages. Let's begin. So in Java, a package is a namespace, and this is why you can have similar named types here being class, interfaces, enums, and so on. As long as they're in different packages, they can exist in Java because they're in different namespaces and there's no conflict. So we use packages to organize related types into one. You've seen this so many times so far in the class, and just to remind us what it was in ours. This is our package. We see it here. Yours could be different. You don't have to use mine. You will see it appended at the very top as the first line of code within your files, and these are all related classes and learning the Java language and some introduction, and I'll continue on like that while we practice. So that is our package. Now you might think, or you might see them as folders, behaving like folders within your PC, but we'll talk more about this to differentiate them. So Java in itself has several packages already available, or what some might call class libraries. We refer to them as application programming interfaces. We've seen some of them so far, and you can use this link, it's in the description, to go and see all of the packages under one roof. So we will be looking later at java.awt and talking more about that. But the one that Java actually makes available to all of us automatically is java.lang and java.lang and your current package. Okay. So I'll be attaching this link in the description. Look out for that. So java.lang has the fundamental classes. Java.io focuses on classes or types. Let me say types because it could be more than classes. The types that handle input, output, or read or write. So the reason why we work with class packages, once again, is to work with the related types and to easily show their correlation or how they relate with each other. So we can easily trace a function we are looking for by their type, as we know where to find the package for the type, and to also prevent conflicts. A package is a namespace in Java, and different namespaces can have, as long as within the namespace there's no conflict, different namespaces can exist with the same kind of type, the same name for a type. And to also control access to types. So we talked about access modifiers, package private, public, and so on. Sometimes you can have your classes within a package. So you can make the ones that you need to be publicly accessible as such, and others as package private for only the class members or the type, the members of that package. So if you would wish to create a package in IntelliJ, this is how you go about it. If you're doing so from within your current project, you can just click on that and say new, then select package. So give it a package name, for example, example domain, and then you will see example domain package here. If you would wish to have a project with a different package name, you go to new project, under Maven, select advanced settings, and you put your package name here. So for example, com dot domain name example dot classes, or dot yt for YouTube. Then you create in a new window. Here's the new window. And here's my package, com.domainname.example.yt. If you have a file with multiple types, let's say a file with different classes, a file with a class and an interface, and so on and so forth, only one of those types can be public. You cannot have the same types in the same class. and all of them are public. And we've seen this when we're talking about nested classes. So new Java class, for example, test name, that's the file name, test name, and that's also the class name, test name. If I create another class, test2, that works. However, I cannot have this as public as well. That will not work. The one that's public needs to be the one that has the same name as the class, and it can only be one. So it will still be an issue like that. So just so you know, that is how it works in packages. Moving on to the naming conventions. So when you're naming a package, conventionally, although we'll address all of it, you're supposed to work with small letters, and I'll walk you through why I did com the main name example.lt. For now, let's discuss the namespace factor. Within the same namespace, there cannot be a type that has the same name as a pre-existing type. So I cannot have, for example, test name here. It's not possible. Java will not allow me to happen. Allow that to happen. However, I can have a different name, for example, rectangle. And here we go. So that works. And this will have no problem with such a class in the API Java AWT .rectangle that exists in the Java API, because this is in a different namespace with that fully qualifiable name, java.awt.rectangle. So the compiler would be able to differentiate between the two by their fully qualified names. Again, we use lower cases to avoid conflicts. Conventionally, as it is in Java types, we work with capital letters. So, for example, in our classes, we start the first letter as a capital letter, and then we continue on the rest as lower cases. And if there's more than 2 words, we use upper kernel case. So to avoid conflicting packages with the types, we use all lowercase. And to avoid having a fully qualified name that is similar to another organization's or other developers' fully qualified name, we are advised to work with the reversed domain name of our company or our organization. So for example, com.youtube.java, depending on what the domain name is or what the package name that you're going for. And if you have different groups within the same organization, you can also decide to work with the domain name, and whatever separation that exists between the different groups, for example the region, before you give your package full package name that you'd like to apply. So all the Java ones start with either Java or Javax, and that is what you'll expect to see from the official documentation. Please note, I'll also share this in the description for all the packages within our APIs in Java. There are some things that are not allowed in package names. For example, hyphens. So if your domain name or whichever way you're naming the package has a hyphen, consider working with an underscore instead. In this example, I'll also attach the link to this in the description. Through this diagram, I got it from the official documentation. And if you have a reserved word, Java reserved word like int, for example, consider working with an underscore after int, right? So it cannot no longer be a reserved word. Then if you have a domain name that starts with numbers, for example, consider working with an underscore before that to fix the issues. So we've already seen import statements, and this just to finalize on that. When you want to use a publicly available package, you need to import the said package by its fully qualified name. For example, Java SQL connection. This is its import statement. So the alternative to this is to work with a fully qualified name where you're using that type. So for example, Java sql.connection. Use this when, say, you're just doing it once and you don't intend on redoing it from within the same file. It's easy to read, but it can become too cluttered if you use it more than one time. So that's why import statements are preferred. So you import the package. You can also import the member, or you work with a fully qualified name. Again, to reiterate, this is an imported member, and if I use that, I would need to use this fully qualified name. Or I might as well import the entire package, and this is how you do it. You use the asterisk after the package name, just to show that you want to import all the members of the said package. So once again, to import a member, it's the package name dot the member's name. I wrote class name, but really it should be the member's name. And to import a member in a class, so let's say the class has nested members which can have them, and you want to only utilize the said nested members. Then after the class name, you will put a full color. You'll put a period, and then you use asterisk to import all the members of the said class. So for example, this imports the package. This imports the member connection. If connection had nested members, then this would import all the nested members. So please note, if I use this, the others are grayed out because they're not very useful. Java will automatically import java.lang, and it will also automatically import the current package for us. So we don't need to work with fully qualified names for the package members when we're working with them. And we also don't need to work with fully qualified names for the members in java.lang class. For example, object. So this is the java.lang class. If you would ever need to work with any of these classes, then you don't need to use the fully qualified name. For example, object, which we had seen in a previous session. Another thing, it might appear like it is, but a package is not a hierarchy. If you would have, for example, java.awt whatever member here, this will import all the members in java.awt. But then there's also another package called java.awt.color. This is a package name. So if you're working in a hierarchy kind of way, you might assume that color is part of AWT, but no, this is just a whole other namespace, and this is another namespace. And even if you look at the documentation, you will see there's java.awt, then there's java.awt color, different namespaces. So just because there is a package that has seemingly part of a name of another package doesn't mean that they are in a hierarchy. Those are different packages. Take note of that. If you're working with static imports, then you'll need to work with the static keyword before you make the import. Please use this sparingly because you might create confusion in your code. It will be preferable to just import the static member, as we had already discussed, to make it clear that it's a static member. But if you intend to use it in more than one area, you might prefer to import it, but use it sparingly because your code readers might be confused on the nature of the member that you're working with. So for example, if you're talking about the maths class, java.lang.math, like that. If you want to import the static members, then you will need to write it as such. For example, specifically, if you want to import the pi member, then it will be math pi. So you need this static keyword because it is a static member. If I remove the static keyword, you'll see that it recognizes that this is a static member. That's how you make static imports. Management of Java packages has become easier with time. So if you can work with within IntelliJ the file view or the project structure to make some changes, and I'll go and walk you through that. So if you're within IntelliJ and you want to view the project, you can just click on here and then select project, and you'll be able to see it like that. If you want to have a different view, for example, to see all the packages, you can do that. And if I switch to the other IntelliJ that had the other window that had different packages, then it will show me that these are my packages. It's easier to navigate. If you want to see your files, then you can do that. You get to see them as files, and you will see the hierarchy, the supposed hierarchy that you can have within a path name for your class. For example, dev/labs/s3, and then the class name with the .java. And we also have the .class files after compiling. Sometimes developers prefer to have a different path for the Java files, for the .java files and for the .class files. If that's what you want to do, you need to click on File, go to Project Structure, and then you change the path to your output. Okay, and that will place your .class files into the intended path. So if you want to find this specifically, make sure you are in modules here. From project structure, you click on modules, then you click on paths, then you make the necessary changes as desired. And that marks the end of our object-oriented programming concepts. There is this link that I'll include in the independent practice section of the description, so you can practice on your own to bring all the concepts under OOP together, from classes to interface to inheritance up to names, up to where we've reached so far. Now, up next, we are going to discuss language basics. If you're already coming from a programming language, this should be very easy. There are going to be concepts that you already know from a different language. Stay tuned.